Hello and welcome back. In our last topic, we mastered Kubernetes services. We learned about cluster IP for internal traffic, NodePort for access to the node IP, and load balancer for getting dedicated IP from a cloud provider or in our case, from the Metal LB. You might be thinking, if I have a load balancer service, why do I need anything else? This is a critical distinction. Services like NodePort and Load Balancer are great, but they are primarily operate at layer 4 of the network stack. They deal with the TCP and UDP protocol and port. They are like building a switchboard operator who can connect to your an extension, but they don't understand the language being spoken. What if you have multiple web applications and you want to route them based on the website name, or like API mycompany.com or shopmycompany.com? Or what if you want to route based on the URL path, like API goes to one service and UI goes to another? This is layer 7 routing for HTTP and HTTPS traffic. And for this, we need to specialize smarter resources called ingress. What's an ingress? An ingress is not service type. It's completely separate Kubernetes objects what provides set of rules for routing external HTTP and HTTPS traffic to your service, which then route to your pods. Think of it as a smart application, a reverse proxy or API gateway for your entire cluster. But there is a very important gotcha here. An ingress object by itself does nothing. It's a just piece of paper, a YAML file with a set of rules. To actually enforce these rules, you need a piece of software running in your cluster called an ingress controller. The ingress controller is a real worker. It's a pod or set of pods that actively watch over your ingress objects you create and then configure its underlying proxy like NGINX or F5 or HA proxy or a cloud provider's gateway to make these roles a reality. If you don't have an ingress controller running, creating an ingress object is like writing traffic rules for city with no policies to enforce them. Installing NGINX Ingress Controller with Helm. While some of platforms like Minikube offer simple add-on enable command, the most common flexible production-ready way to install Ingress Controller is by using Helm, the Kubernetes package manager. Let's install official NGINX Ingress Controller using Helm right now. First, we need to add the official Ingress NGINX Helm repository. This is like running the app store to your package manager. Let me switch to the terminal, official Ingress location, Kubernetes github.io, Ingress Nginx. So it's already there. To updating repos, I'm using Helm repo update. And as you can see, I have MetalLB, Ingress Nginx, and JetStack here. Now we can run the Helm install command. We'll name our installation Ingress Nginx. Tell it use the Ingress Nginx chart, and especially that it should be installed in a namespace called Ingress Nginx. That the create namespace flag will conveniently make the namespace for us if it doesn't already exist. So this is a command, and as you can see, we have namespace and then create namespace to create the Ingress Nginx namespace, and the release name is Ingress Nginx. The Helm chart is now deploying all the necessary component. The controller deployment, its services, and RBAC role, and everything else is needed. We can verify the installation by checking the Ingress controller pod in Ingress Nginx namespace. And as you can see, the Ingress Nginx controller pod is running and in a ready state. Once you see the controller pod in running state, your cluster is now ready and actively listening for Ingress objects to create. Another thing to check is basically the services inside the namespace. So if I get the SVC inside the Nginx Ingress, you can see that Ingress controller has this external IP 192.168.2.1, and it's listening on port 80 and 443. So an ingress role is built for these three simple criteria. So the next step is to understanding the ingress controller. Let's back to the slides. So here is the role of ingress. We have API version, we have kind, the optional host. This is a domain name like foobar.com. If you provide a host, this role only apply traffic for that specific domain. A list of path. This is the URL path like bar, foo. The traffic must match this path to be routed. The backend. This is the service port combination where the traffic should be sent if it matches the host and path. Let's create one. We can use this imperative command, which is useful to know for your CKA exam or your for some. I'm backing to the terminal. I can use kubectl create ingress. This will create the ingress object for us. This single command create an ingress. It defined a role that says any traffic for host contuso.com on the path echoserver-API should be sent to the service name echoserver on port 8080. But as always, a declarative YAML manifest is clear real-world way to do this. So I already have this manifest in my ingress YAML file. The file is look like this. Here you can see the structure clearly. The host is contuso.com. We also have list of path. The path echoserver/API points to our backend service echoserver. A crucial detail, the path type. Now you want to pay close attention to the last line. The path type is exact. This is critical detail. Exact. This means the incoming URL path must match the role perfectly. In our case, contuso.com/echoserver/API will match. But contuso.com echoserver/API/ with thrilling / in the end will not match and will result in 404 error. Prefix. This is other common type. It matches the path and anything after it. If our path was prefix, here instead of exact, it was prefix, then it would match echoserver/API, echoserver/API/ echoserver/API v2/user. Prefix is generally more flexible, but exact give you the prices control. Inspect and troubleshooting ingress. Let's see what we have created. So I haven't applied it yet, the manifest. So now I'm applying the ingress. Let's get the ingress resource. Okay. The get command gives us a high-level summary. The most important column here is address. This is the IP address to our ingress controller load balancer, the single front door for all HTTP traffic. This is not updated yet, but soon we should have the address of the load balancer here. So let's move to the next step, and we can check that information, the address later when the load balancer, when the ingress update the manifest of our ingress. In the output, fantastic for debugging. Look at the backend column here. The service echo server not found. This is the Kubernetes telling us you created an ingress role to send the traffic to a service named echo server, but I can't find it, the server, or that service has not any ready pod. Let's fix that. We have created the echo server pod with the right label and echo servers to expose it. So I'm gonna create the echo server pod. This is run command, echo server. The image is official echo server of Kubernetes, and the port is 8080 and app name is echo server. And to expose the service, I'm going to use the simple command create service cluster IP echo server, and the port is 8080 to 8080. Now let's wait for a few seconds that controller to sync and describe NGINX Ingress again. So let's describe the NGINX echo server again. Success, the error is gone. The ingress has found its backend service, and that service has found a ready pod which is listed in parent. The entire traffic path is now healthy. So let's again get the ingress to see the address. The external address here is 192.168.2.1. The next step is accessing the ingress. Now for the final test, let's access to our application from outside of the cluster. First, we need the IP address of our ingress controller, which we saw in the get ingress output. So the one way I used was like checking the ingress. Another is to getting the load balancer status and see that the IP address is 192.168.2.1. Next, because contuso.com isn't the real DNS name I own, I need to trick my local computer. We have two ways to achieve our goal. First is to edit the hosts etc host file to tell my laptop or computer that contusa.com should point to our ingress IP address. So this is a very common way to do it. You can edit etc hosts, and here you can add a record. So the IP address, and then the IP address should be 192.168.2.1, and then the host name is the contusa.com. It's like this. Now my computer thinks contusa.com lived at our cluster ingress IP. Let's try to access it using wget. So I'm gonna use this and see that this is working well. So API, we got the API and the result is in API. As you can see, we have the HTTP response here. And 200, it's connected, was routed to ingress, and our echo server pod responded. The second and easier way is to use the curl. So I'm going to remove the record from the etc hosts. This is my recommended way to testing the ingress resources when you don't have any DNS record for your service, or you are in a transition phase when you want to move your application from one location to another and you want to check that if it's accessible or not. So I'm going to use -- resolve in curl, which allow me to replace the public DNS address with my whatever record that I want to check. So I'm using contusa.com port 80 on 192.168.2.1, and then I'm checking the contusa.com host name here and echo server API. This will replace the host name and with my current IP address. So if I'm checking this, you can see that the result is okay. The HTTP is 200. And then we have the old information that we use to connect the cluster. Now let's test what happened if we added thrilling a slash. Remember, our path type was exact. So I'm going to use again the curl. But here, instead of /API, I'm going to use /API/. As you can see, we are getting 404 or not found. A 404 not found. This is perfect. It proves our exact path rule is working. The ingress controller saw the echo server /API/ did not exactly match echo server /API and correctly reject the request. So let's change the path of ingress. Let's edit ingress. It was echo server, and here in the path type, let's use prefix. Instead of exact, we are using prefix, and it's edited. So now we're describing the ingress and see that it's working, it's synced. So let's now test the /API/. As you can see, it's responding with the result. It means that all incoming traffic to this route goes through the service. Great. Our ingress is working and routing HTTP traffic. But in the real world, we almost never want to send traffic in plain text. We need to secure our application with HTTPS. Let's add a TLS certificate to our Contusa ingress. This is a two-step process. First, we need to have a TLS certificate, a private key, and public certificate. Second, we store that certificate in Kubernetes secret and tell our ingress to use it. For this tutorial, we will create our own self-signed certificate. In a production environment, you would use a real certificate from the certificate authority like Let's Encrypt. Let's go to the terminal. Let's use OpenSSL to create a new private key, TLS key, and the self-signed certificate, or CRT, valid for 365 days. The most important part is the CN, or common name, which we must match the host in our ingress contusa.com. So I'm going to use this command, OpenSSL. This gives us two files, TLS key, our secret private key, and TLS CRT, our public certificate. Now we need to get this into Kubernetes. The Ingress controller can't read local files, but it can read Kubernetes secrets. We'll use the kubectl create secret TLS to create a special type of secret designed for exactly this purpose. So I'm going to use this, and I will name it Contusa TLS secrets. And I'm using key and cert. Okay, perfect. The secret Contusa TLS secrets now securely stored our key and cert inside of the cluster. The final step is to tell of our Kubernetes to use this secret. We will edit our EcoService Ingress YAML and add the new TLS block. So I'm going to use a new YAML. I'll name it ingress tls.yaml. Here, as you can see, we have added the secret name and added the host name under the TLS section. So these are the two new things that we added to the manifest. So I'm going to use, I'm going to save file, and then I will apply the file, ingress TLS YAML. So these TLS blocks tell the Ingress controller for any traffic to this host contusa.com, use the certificate found the secret, Contusa TLS secrets to terminate the HTTPS connection. So now let's look at our Ingress objects again. As you can see, there is a new port here, 443. This confirmed that Ingress controller is listening on both HTTP and the new HTTPS port. To test this, we can use the same curl command we use for Contusa, but instead of port 80, we'll use 443 here. And instead of HTTP protocol, we are going to use HTTPS protocol. And then we will check the API because we are using exact as a type. So if I press this, we will see something interesting. As you can see, right now it responds with this particular answer. Curl failed to verify the legitimacy of the server and therefore could not establish secure connection to it. It's because it's a self-signed certificate and it's not trusted by my system. There is a flag for curl -k, and this flag is ignoring this security check and it will connect to this. As you can see now, it gives me the response back. So next time when you want to check the self-signed certificate with curl, you can use -k flag to ignoring the certificate authority. But to secure your environment, I'm highly recommend to use a valid certificate in first step, like signed by authorized authority like Let's Encrypt or any other certificate authority that trusted by your secret store in your system, or adding the root certificate to your system. It's basically good for organization to manage securing their interconnections between systems. And that's the power of Ingress. It's smart layer 7 router for your cluster and lets you manage all your application traffic with a single entry point, routing by host and path to all the different backend services. Thank you for watching. I'll see you in the next topic.